at 7 o'clock so that we have enough time for a full presentation from Harley, and then perhaps appropriately some music and discussion about the undoubted controversy we shall have through the evening, okay? Now, also, what I'm going to do, hopefully this is a little bit experimental. We're not going to answer every question. You know, everybody always wants the answers. Maybe we'll raise more questions or more areas for people to look into. Maybe we'll give you a little bit of answers, but more, hopefully, provoke people. You know, as Lynn said this morning, some of you will engage in in-depth work in certain areas, whether it's Gauss, the developments after Gauss, or some of the things that led into Gauss. Leibniz did a great deal of the work with some others, created the calculus. You know, something that really is largely misunderstood because what most people get is a rote, memorized way of calculating things. But rather to understand where the calculus came from, what are the principles. And this is what will perhaps give you some, you know, beginning idea of what we mean by a principle, a universal principle. Even that's a funny idea in the 21st century. Some of what I'm going to reference is from that standpoint. And then we'll hopefully have some demonstrations of it. And then I'll come back and do a little concluding point. But, I mean, the starting point for what I want to talk about is to sort of situate what Lynn did. What's Lynn's idea? It's located in a tradition. I mean, Charlie was just asking me, you know, how do we know that Lynn's ideas are going to work? Well, because they're not completely de novo. They're not simply, you know, and this is what you have from creativity now. Well, a new idea is something that somebody burps and it comes out. Because if you thought about it, it couldn't be new. Because if you had an idea in your head and you were thinking about how it connected to different things, that might have been caused, you think, by the other ideas. It's not really your idea. If you study history and you get an idea, isn't that idea just something you got from other people? No, a really new idea is something that you kind of burp and it comes out. Now, of course, really, if you think about it, it's completely upside down. Okay? A true creative insight is something that you produce as an addition or a further development of things that went before you. You're improving on it, but you're also building on the basis of prior ideas. Because you're trying to further the development of human ideas, and you're trying to communicate them to other people. You really can't communicate so well the process of a burp to another person. Well, you know, there I was sitting there, and here's what I'd eaten all day long, and here's how much sleep I had, and that caused me to burp. Why don't you try it? It doesn't, you know, you don't get ideas that way. I mean, well, you say, people laugh, they say, think about how much people's ideas about creativity, let's say, particularly when it comes to, quote, art, is, well, the most creative person is the guy who gets up on the stage, and when the mood hits him, he smashes his guitar over the microphone, rips his shirt open, and, you know, pounces on the first female in the first row of the audience. And that was a burst of extraordinary creativity. A sort of a once-only experience, I hope, you know. Now, or, you know, but what is really an idea? Now, Lynn bases himself on a tradition. History refers to it all the time. And yet, he made a significant development and contribution to that. Something new. Something that had been sort of presaged by Leibniz's work in physical economy. Because what was Leibniz looking at, and what did Lynn then look at? And what did it stand in contrast to? People want to know why Lynn isn't popular. Well, to a large extent, what we represent is the antithesis, though that's not the origin of it, but Lynn turns out to be the antithesis of almost everything that occurred in the 20th century, with a few exceptions. Because what happened? what Lin looked at, what Leibniz looked at, is physical economy in the following sense. See, the problem that most people have is they think that in order to understand something, you have to look at it objectively. That is to say, you have to sort of take yourself out of the universe somehow, or out of the room at least, and then you look at it. And you observe things, and that's objective. And then you sort of, if you look at it long enough, you make generalizations about what's going on inside the room. Or you might be watching a room full of billiard balls or things that are interacting in some way. And so the idea is, and I'll come back to how this developed in the 20th century, all you can do is sort of record these phenomena as sensory experiences. And you see, as David Hume says, colors, shapes, and hues. You're all taught empiricism, directly or indirectly, either in a philosophy 101 course or whatever, or this is what you're generally taught of the principles in all these courses, economics, psychology. Think about it. Think about the uniformity of it. In economics, you're taught all that generates an economy is the desires and pleasures that people have, and in the marketplace, the amount of desire people have for some commodity generates somehow a price. And the markets trade these things back and forth based on the relative pleasure or demand for certain kinds of commodities. And the marketplace regulates the price and regulates the production. So you can't, and in fact, from any economics textbook standpoint, the idea of injecting a principle, well, we want this to happen. We really want to have technological growth, so we have an intention that we put into the economy. That's considered a violation of the economy. That's what the free market is. That's why these guys were all against government, big government. You can't. They're not really against government. They're against human intentions. They're against the idea that human beings have a mind and a purpose. You're never supposed to express that. Well, at least not in the realm of economy. Take psychology or sociology. What do? The idea is you observe the behavior of people and you make generalizations about them. Of course, much of this is complete bunk. And a universal to these guys is supposed to be a statistical generalization. 91% of the time when people, get married in a building that has 14 windows, they have 3 children. And this we take as a general sociological principle. So if you want to reduce the number of children, you reduce the number of windows in the institution. Or you find, you get all these statistical correlations. Children of divorced parents have this behavior. And there's always in some ways you're going to find a certain truth to it. But the problem is, you've never found out what caused it to happen. Therefore, you don't really know what to do about it. And then if you say, well, look, why don't we try to do something about it? They say, no, you can't do that. You're violating the experiment. You have this in psychology. You have it in, fundamentally, you have the same thing in physics. What's the problem in so-called the hard sciences is all you're going to have is statistical generalizations of the data. Anything else is an interference of the mind or the projection of the mind. And there's a big confusion of this from quantum theory and from Heisenberg, the so-called uncertainty principle, with this idea that when you observe something, the light wave disturbs the object. That's true. But even Heisenberg didn't think it led to all the conclusions that people have drawn from this, of the sort of irrationality or the unknowability of the universe. You might have to use indirect means, but science is not simply based on statistical generalizations of sensory experiences. Now, there's another side to this. And there's not a simple formula for this stuff. But there's another side to this. And that is, where then are humans allowed to express themselves in intention? You can't really do it in society because that interferes with the proper free market economic relations, which are purely, if we want to deal with the real objective side of things, simply the individual feelings of individual human beings. You can't express it in science because science is the hard external world. So you express it in so-called art or leisure time or then you just can, anything counts. No one can say anything about that. But that's where the human beings are. The odd thing is the human mind expresses itself only in its pure irrationality, in its pure arbitrariness. And no one can interfere with how I feel about things because I'm sort of the ultimate observer of my own feelings. There I don't need a statistical generalization. I can simply report to you every moment how I feel about things. Right now I like you. You better leave because in 5 minutes I might hate your guts. And if that happens, well, that's just me. I have a right to that. If you do something I don't like, I hate you. Okay? If I happen not to like people of a certain color, fine. You can argue that I shouldn't express that, but that's just how I feel about things. And of course, then people go off and they say, you get all this stuff, which is much more of a racialism than people think. Sure, there's the oppressiveness of, the dominant society and so forth, but let's face it, often what you get in response is the following argument. Well, people, for example, white people have a gene, and it's a racist gene. They're genetically racist. Okay, I can prove that because notice that over the recent period, the people who have been dominant have been of generally lighter shades, because nobody's really white except for a few people up in Finland somewhere or something, I don't know, northern Sweden or something. Anyway, you're hard-pressed to find a white person, okay? There are a lot of pink people around, but there's not that many white people, okay? But there's people of lighter shades say, well, they've been dominant and they've put other people down and they express all these things, so therefore I think they're genetically racist. Okay? Well, fundamentally that's a racist outlook. You may not like the fact that oppressed people can be racist, but it happens to be true. Okay? Now, you get these kinds of, but see, in this area people can express themselves. They can express their art. And people get very upset. We say, well, how can you tell me that this is not true? Well, one of the things that happens, and the classic distinction here is, and this was argued during the 19th and 20th century, is that there's a radical distinction between what was called somewhat in German Naturwissenschaft, the study of nature or science of nature, and Geisteswissenschaft, the study of mind or the activity of the mind. And these are two radically separate things. You can't really unify them. Well, here's an interesting thing that comes up. You heard people often say, well, what's a universal physical principle? How does a universal physical principle work? Well, here's an interesting problem. If the world is divided into two completely hermetically sealed compartments, one is Naturwissenschaft, the study of objective nature, and the other is the subjective realm, well, then there are no universal physical principles. Because to be universal, it has to be a principle of everything, of the universe. And if there's two separate universes, two compartments that are separated as completely distinct types, then there's not one universal set of principles. And frankly, if you look at the world this way, you are almost by definition schizophrenic. You're trying to live in two universes at one time. And it actually leads to a certain kind of paranoid schizophrenia in the literal sense. Because what happens is, if these two worlds are completely hermetically sealed, they're totally separate, then when you exist in one world, and since we happen to be creatures of the mind, to a certain extent we can't help it, then how do we deal with other human beings or the rest of nature? We have to try to find out the secret code. Maybe there's a secret ritual that allows me to control other objects, including other human beings, or maybe there's a secret code to the way the universe works. And I have to sort of find out what that mysterious code is? Well, think about it, right? Isn't it the case that, for example, what is gambling? Or what is the idea of the free market? If the free market is completely a zero-sum game, economics, for everybody who wins, there's a loser. Well, then how do you get yourself to be on the winning side? Or how do you get the slight margin that allows you to come out ahead? You have to figure out what is it that this mysterious invisible hand accepts. Is there some way to manipulate it? Is there some way that if I find the secret code, the little green men or the little gods that control this otherwise unknowable universe, then I might come out ahead. Man, this is behind gambling, for example. It is the whole idea of in a speculative free market that somehow you find some little statistical correlation that puts you one step ahead. It's a good guess. And of course, ultimately, what you realize that there are powers that control this. There are ruling forces that seem to make the game come out a little bit uneven. And your job is to propitiate them. Make them like you. Make them be submissive enough that they'll give you something. And this induces something called paranoid schizophrenia. You're walking around trying to figure out how to behave, what motions to go through, what are the right things to say, what are the proper things to say in certain company, how do you behave to get a good grade, to get a paper that's going to give you a good job, that's going to put you a little ahead of everybody else. It's paranoid schizophrenia. It's the idea of two completely separate worlds that have no controlling lawfulness between them. You can never really know it, so you have to propitiate it. And this is what leads to what Lynn was talking about. You get literally a pantheon of accepted religious beliefs. Yeah, religious can be, they can be mystical, they can be all kinds of things, okay? And then, of course, you have one force, one power that tells you what's allowable to think even within that pantheon. And these are the people who run the whole show. And really what makes society, what's made the history of the human species, largely characterized over longer spans by the dominance of a small group of people over the larger one, and a few moments where, due to the creative intervention of certain individuals, the human species has been able to make remarkable advances, and I'll reference that in a minute, seemingly outside the guidelines of this distinction. And what Lynn is talking about when he says we could reach a new standard for humankind, it's not to say we're going to create a new human being. It's to say we're going to take that which is human and has always been human, has been the only way in which we've progressed, and make that the standard of human society. Make that the means by which we exist for each human being. Now, the idea is to show that those kinds of ideas are themselves actually universal physical principles. Now, what did Leibniz do? What did Lynn follow up on? Leibniz pointed out a simple point. I'm not going to, that it was, how did human society progress? And it's an important thing to see. There's a big mystery in this, particularly if you look at it from the standpoint, as I said, of these modern, logical positivists, pragmatists, the free market, reductionist psychology, and so forth. Because there's a great mystery. The people who say, well, really human beings are just like, they're complicated animals. They're complicated apes. We're driven by the same things. Darwin, the same point, right? We're all just trying to get our genetic material to the next generation. And it's a great struggle. I mean, what Darwin wasn't genetic material, that was added in. That gives us modern Darwinism. It's a great struggle to get each individual creature is struggling to get his or her genetic endowment to survive. And some of them are better at it, and they survive and their genes dominate. Same thing. You got to realize all these are the same principle over and over and over again. It leads to junk science, like much of what we have in molecular biology today and so forth. Now, what does Leibniz notice? And what does Lynn elaborate on? Well, the human species is very different than any other animal. The human species, and in a very straightforward way, animals in general have a limited population capability. They're limited by what they can do. They're limited by the fact that they can learn only in the most limited sense. You might have this among some of the higher primates. There's imitative patterns amongst other animals, birds and mammals. But they generally exist within a very limited pattern of behavior. And the marginal instabilities cause their populations to reduce rapidly to certain limits. So, for example, you're never going to have more than a certain number of elephants in Africa unless human beings intervene and keep the elephants alive. You're never going to have more than a certain number of primates, apes, higher apes in the world. They only have a limited capability. They need a certain amount of habitat. There's only going to be a certain number per square mile. They're not going to change the nature around them. They don't come to know anything. They don't generate hypotheses. Frankly, if people actually thought about it, the idea of any other animal but a human being generating a hypothesis is almost an absurdity. People can project all kinds of things into it, but they don't do it. One of the reasons you don't do it is they don't communicate it. Now, what do we notice about the human species? The human species essentially, in principle, has no boundary on the amount of population it can support. And the history of the human species has been radical increases over the entire span of human existence, somewhat punctuated by significant creative breakthroughs that have shot human population capability up. But overall, the potential population density of the human species has increased. In fact, it has increased exponentially. So if you looked at a chart, and we've had this, I'm not going to go through it. If you looked at a chart, and if you go back, as Lynn said, about 2 million years, you're going to find that the human species had, a population not that different than a higher primate. Probably never more than a few million. Then you begin to look at things where the human population grows over periods from tens of millions into the range of hundreds of millions probably about the time slightly before the Roman Empire. Then the human species goes through a long period where it doesn't develop very much. But you get to the Renaissance in Greece, and there's some upticks in the Chinese Renaissance, where it probably goes up to about 500 million, and then it goes back down. And then you get to the Golden Renaissance of Italy, and soon it shoots up from about a few hundred million until at the end of the 19th century, at the end of the 18th into the 19th century, you get the first billion. The first population, which is 1 billion people, somewhere in the early 19th century. Then you realize all of a sudden, from the 19th century to the 20th century, we get from 1 billion to 2 billion. And then from the early 20th century to the 21st century, from 2 billion to 6 billion. Now that's with a lot of problems. Realize that the 20th century was a bit of a disaster overall. We should have probably gotten ourselves to somewhere over 10 billion people, minimally. Now, no other creature on the planet has that capability. Each of these moments of progress are characterized by the introduction of new scientific principles which allow us to generate new technologies. And this is what Leibniz looked at. He said Leibniz was looking at, look, human progress has depended upon the development of the productive powers of labor through artificial labor. And he was particularly looking at the introduction of heat-driven machines, steam engines and whatnot. And if people had a productive outlook, and one thing we're going to do tomorrow is we're going to go visit this dam, and hopefully people will begin to get an idea of what it really takes to do something. How much power over nature it takes to accomplish something. I mean, I often wonder, how many people sit here in this room and think about the amount of productive activity that goes into allowing you to sit here? Particularly, I think if you're an environmentalist, you should think about this. I mean, look at the light. Where does it come from? Do you ever think of tracing back the light from this room? There's an electrical cable that comes in here. Ultimately, it's connected to a system, an electric grid, a power grid. There's condensers, transformer stations, huge pylons that carry electricity, probably from around here, I guess maybe from some hydroelectric station, where a massive dam was built. Turbines were constructed. All that's going on right now to get this electricity into this room. How much science went into that? How many discoveries in physics, in materials? How many skilled laborers? Now, how many people does it take to support that? Because everybody says, well, we have too many people. It's an amazing thought. You have no, at least think about it. And so before you said something like that. Because let's say we took away a couple billion of these people to make things more comfortable, the lights would go out. The food wouldn't show up. The roads wouldn't be repaired. The numbers of doctors and so forth would go down. So what Leibniz looked at was real economy is studying how this kind of transformation is accomplished by human intervention, by the discovery of principles. And I'll come back to Leibniz when we go over to what Sky and company are going to do. By discovery of principles and the generation of certain kinds of tools, both mathematical tools, technologies, that increase our control over nature, which allow us to increase the amount of density of power that we have. And this was basically the outlook of Alexander Hamilton, the founding fathers, Ben Franklin, who was, by the way, a scientist. He was considered one of the leading scientists of the 18th century. He was working electricity and other areas. This was the policy of the American Revolution. It was the policy of people like Lincoln, what they called internal improvements. When Lynn talks about infrastructure, this is at the core of the tradition of the American system of political economy. Now, what Lynn in particular was looking at after World War II is very much the same kind of thing, but he wanted to actually identify the nature of this and the kind of scientific physical outlook and the nature, and what was really the nature of human cognitive, what's the nature of creativity? Because clearly the essence of human development is expressed in the human mind's ability to generate a new kind of idea. Some idea that expands our understanding of the universe, that solves the problems in front of us. Now, what did Lynn in particular do? In a sense, Lynn went directly at this question of Naturwissenschaft, Geisteswissenschaft, which leads to something very interesting. Okay? What are we looking at here? How does an economy work? And see, this idea of a couple of generations, this isn't new with Lynn. What is a human economy? We are constantly engaged in activity using nature to draw upon the powers of nature to control them. And that's how we know that the progress of our ideas are true and that nature operates on that basis. If nature didn't have a principle of developmental progress in itself, then our ideas about controlling nature wouldn't work. Because we're really creating things that in one sense aren't natural. Things begin to have, electricity isn't natural. I mean, there's lightning, there's static electricity, but the kind of controlled electrical currents that human beings create don't occur in nature. We create them based on the fact that we discover the principles in nature that allow us to control electricity, which means electricity is controllable. Therefore, nature has in it principles coherent with the development of human ideas. Now, what Lynn looked at, you say, look at anything. How do you really have to run an economy? Well, you always have to look into the future. You know where you've gotten your resources. You look into the past. You look at how you got here. Now you're working with certain resources. You need oil. You need certain kinds of minerals, materials, metals. And you realize that as you necessarily expand the human population to sustain the population that we have now, you're going to be using these resources up, or you're going to run into some problem. It may not be simply the use of resources, but problems are going to come up. Some of it is resources. For example, if you're constantly oil, there may be zillions of billions of barrels of oil. But one of the problems is that you have to keep going further and further out to get it. You have to dig deeper and deeper down. You have to transport it further and further. Moreover, oil has other purposes. Petrochemicals, fertilizer, materials that we need to replace other depleted materials. So as we concentrate our efforts on expanding to get the oil, we're using more energy to go further out. We're depleting certain other resources. So we know that in order for us to have the proper energy densities in the population, the proper allocation that people can live in certain places where they're going to be needed, we're going to have to come up with some solution to the energy problem. And it's a big problem because think of all the material that goes into pipelines. How far out can you have your electric grids? You lose energy. Even if you come up with some ideas to reduce the amount of loss of electricity in transport over cables and lines and so forth. So you have to solve all these problems. At a certain point, you realize that you're going to have to come up with a new energy source, something that's denser. Because you got a larger population, you're going to need more people now because you got to come up with you got to put the effort into the scientific research. So how do you do this? Well, first of all, you look ahead 25, 50 years. Where's the horizon? What's the boundary condition of what we're doing right now? What are the pathways? What is the allocation of human activity? What are the development of nations? What new nations are going to develop under these circumstances? And you have to figure out what are the pathways. In this kind of situation, what are the portions of activity within a nation of certain kind of labor? What are the lifespans that you need? What are the health conditions that you need? What are the medical problems you have to solve? And then you say, okay, well, 50 years from now, we have to have a certain series of breakthroughs that define science drivers. We're going to have to introduce nuclear fission. We're going to try to get to nuclear fusion. And we're going to be able to use the petrochemicals for other purposes, and that's going to allow us to advance other technologies. But this means scientific breakthroughs. You can't exactly predict a scientific breakthrough. But you can do two things. You can deploy for it, and you can figure out what's the kind of thinking that's going to produce these kinds of breakthroughs. And then certain very funny things happen. And you begin to see how you can't be linear about anything. Let's say you say, well, 50 years from now we're going to have to replace all this with at least a significantly higher percentage of a higher energy density resource. Something like nuclear fission. And at least the ability to get to fusion. Because to get to fusion, you need already a very high density economy. You're going to have to produce massive kinds of research projects, machinery. You're going to need new types of machine tools, and so on. Well, you realize, well, wait a minute. If we try to get to this point 50 years from now, we're actually going to have to use our present resources faster. Because we're going to have to be already building nuclear fission. We're going to have to be doing certain kinds of research projects. And my projection of how long present energy resources are going to be adequate to maintain the population really doesn't work. It's probably, if we deploy to get to 50 years on a linear projection, we're probably going to end up short. We won't have enough to get to 50 years because we're using certain things up faster. Therefore, my time horizon comes back. And in a sense, you're going to have to try to adjust. You're going to have to find the curvature of the pathway to get from today to the necessary technological breakthroughs in the future. For example, if we're going to develop the mineral resources in Siberia or in some of the more difficult climates in the world, we're going to find that space research, moon landings, Mars explorations, the kinds of data we get from medical research on what the body goes through under these circumstances is going to give us the ability to carry out activity on the planet more easily, more efficiently. Space exploration becomes a science driver, focusing attention on the extreme conditions of biology of the human species that allows us to do things on the planet Earth in a much more effective, broad-based way. However, if we do that, to develop the resources, the strategic resources, we're going to need more and more portions of the human population engaged in scientific activity. Now, the other question is, how do we know that if we allocate resources to these kinds of frontiers that we're going to get the breakthroughs? Okay? Well, you know, here's how it works. You have to understand how the human mind works. You have to understand how you create an environment within which people are as creative as they can possibly be, in which you're focused on only that part of the human sense of identity which makes us human. And that's our cognitive, hypothesis-generating, creative capability. You create an environment in which the level of discussion, the way people sound, what people do in their leisure time, the type of leisure time, creates ever-increasing capabilities of the human individual. That's part of the economy. What does that mean? That means that the subjective creative powers of the human mind is part of the physical economy, and it has a physical effect. In other words, the laws of human thinking, which are expressed largely in art, drama, poetry, is a physical force in the universe. The hypothesis-generating capability, the ability to generate a new universal principle, allows us to transform our relationship to nature, has a physical effect in the universe. We control electricity, we control nuclear energy. That doesn't exist without the hypothesis of the human mind. You know, we may be a speck in the universe, but we've changed the nature of that speck. There are things going on this planet that don't go on anywhere else in the known universe. So it's unique. It has an infinite effect in that sense. Now, what this means is actually what? The lawfulness of Naturwissenschaft and Geisteswissenschaft are the same. It's one universe. Otherwise, the mind could not have a physical effect simply through its idea-generating capability in the universe. Now, however, that means something else. That means that principles of classical art are susceptible of the same judgments of truth as physical scientific principles. Culture, ideas, art is only truthful if it communicates the types of ideas that improve the creative capabilities of the listeners as manifested in the generation of ideas that make the human species more potent in the universe. Now, you cannot like that as much as you want. But you have to recognize that that's a standard that exists. You can rebel against it. Okay? Now that basically was Lind's discovery. Therefore, because the human mind is effective in the universe, the nature of the universe has a quality like the hypothesis-generating device of the human mind. And by the way, since the human mind, the one big problem is, right, everybody thinks of the human mind as something that's outside the universe. But of course it isn't. It's right here. It's part of nature. Not only that, nature produced it. And this doesn't make any difference whether you think, these people, whether you believe in a theory of development of the human mind out of the pre-existing physical universe, or you think God came in and whatever. It doesn't make any difference. Because if it was some creator that just came down and said, zap, he was also the same creator of the universe as a whole. And he made you coherent with that universe. Otherwise, you wouldn't be able to survive here. Either way, it comes to the same thing. Now, what you find in the 20th century is very fascinating, because what do you get? And I'll make a reference to the Moonies here, because it's true. What did you have in the 20th century in the United States in particular? And I'll go through this a little quick because I want to get to this other stuff. In particular, is you had logical positivism, radical empiricism. Some of you may have gotten this, but many of you were affected by this. It was introduced into linguistics, philosophy, theories of mathematics, and so on and so forth, game theory, economic theory. All these guys, Rudolf Carnap, reduced virtually every statement to a probabilistic statistical generalization of singular experiences. And he said that's the universal language. Okay, this is what Chomsky comes out of. That's why he defends Russell. This is Karl Hempel, who many of you may have gotten in some introduction to scientific method. What's a hypothesis to him? You take a generalization, you make it a statistical generalization, say, well, I'm going to hypothesize that 99.9% this is what happens. Then you do a series of deductions off of it, and you test the deductions. And there's no thinking in it, really. Okay, you have all the formalisms of the 20th century. This is artificial intelligence. Human beings are nothing but digital devices. And if digital devices are limited in some way, then human beings are limited. In effect, there's no such thing as a universal principle. This is something Harley talked about up in Seattle, Occam's razor. Never assume anything that you don't have to. There's never any metaphysical principle. There's never any thought. There's never any idea. If you can reduce it to a simple linear generalization, leave it at that. Well, it's the same thing you get in Euclidean geometry. If you can reduce a circle to an infinite number of tiny little lines, let's assume that the circle is really linear. Or we can reduce it to that for calculational purposes. And to the positivist or the empiricist, the difference doesn't make any, we're going to ignore it. The fact that a curve is a curve and a straight line, no matter how many of them you have, is still a series of straight lines and has no curvature, is left out. And in one sense, as people have noted as an anomaly, if you reduce a circle to an infinite number of an infinite-sided polygon, you have one huge difference. The circle has no angles. The infinite polygon has an infinite number of angles. So they're in one sense completely different. But what's really important when you look at things like the calculus and all this kind of stuff is that the actual existing idea that makes something give you a totally different power is lost. Because in every case, when the human mind generates a hypothesis, it's totally different in one sense than everything that went before it. It changes your relationship to everything. Just like when you generate something like, when you learn something like subatomic physics, you've begun to look at something you can't see at all. You're doing it off indirect measurements, off hypotheses about how this works. And you're constructing an image of something that you can't see at all. Out of pure capabilities of the human mind that are then effective in controlling nature. Now, in the 20th century, this is completely hated, and that's why science has stagnated so much, despite what you think. Virtually nothing of significance has been created in 20th century science, certainly after the first third of the century. Because we're stuck in dogmatisms that reject the universal hypothesis creating capabilities of the human mind that Leibniz understood, that Da Vinci understood. All these guys, these were the generators of modern science. So Leibniz, the calculus, Kepler, gravitational theory. And what are the relationships amongst within the universe? Now, the way in which Lynn has described this recently, what happens? You have a physical principle which basically tells you, it's not a series of things that tell you where an object is. It's a principle of relations of everything in the universe under that principle. Gravitational relations are not just this attracts that. It sets up a whole series of harmonic relations, as Kepler understood it, amongst all the main bodies, for example, in the solar system, and has implications beyond that. Now, what happens when you introduce a new principle into that existing relationship? For example, when you begin to look at electromagnetic effects in the solar system, and these are real effects, then what happens is these two principles together give you a new set of relations amongst relations, and a whole new conception of what the ordering principle of the solar system as a whole is, taking into account now something that you barely knew existed before. And this is the way the mind actually works. Now, how do we begin? And why was this attacked? Russell, for example, this is sort of the beginning of the Principia Mathematica, the reduction of all mathematics to a strict, effectively digital formalism. You can't even get the totality of arithmetic out of this, or out of any formal system of this type. Frankly, Plato proved it in the Parmenides. Cusa proves it again. No formal system can generate a hypothesis, can generate a totality. Yet, we have Principia Mathematica, which is basically what we call, in effect, set theory today. Not Cantor, but Russell. Russell rejects Cantor's concept of a totality. Russell attacks Leibniz, or he does it in a very funny way. He basically says that Leibniz really was like me. He just said all these things about happiness and the best of all possible worlds as somewhat of an aside, and underneath it all, he's basically an Aristotelian logician like I am. Okay?
Russell said that?
Yeah.
Yeah, I heard that.
Okay?
Well, he did say Leibniz was the best logician ever.
Yeah, because he was a logician. He attacks Riemann. Okay? Why? Because to Russell, the idea that the human mind has a unique place in the world is anathema. He hates it. He hates people. He said it. It's not, you look at his own writings. He hated people. He thought we had to have maybe 1 billion people. He was a racist. He thought we should have war and plague periodically to keep the population under control. He hated the human mind. But he's considered at places like UCLA to be the greatest philosopher of the 20th century, blah, blah, blah. He's also considered to be the great pacifist, yet he wanted to bomb the Soviet Union in 1946. He's basically the author of modern utopian strategic outlook. Now, what's interesting about this moon question, because the Moonies have this crazy pantheon approach to religion, is there was a group in the 1930s called the Unification of the Sciences, which was led by a bunch of logical positivists. Carnap, Hempel, a guy named Neurath, and others, who had this outlook. Everything can be reduced to simple logical relationships. The human mind doesn't count. In 1972, Moon revived this, the International Conference for the Unification of Science, International Congress for the Unification of Science. You might think, well, okay, but he's a kook. He didn't have anybody there. No. You know who was at these conferences? Eugene Wigner, leading physicist. Alexander King, who headed up the education section of the Office for OECD, the Office of Economic Development for the European Community, from 1963 on. Friedrich von Hayek was given an award by the Moons in the middle 1980s. This is the guy who's considered the guru of modern free market economic theory. He's the granddaddy of Milton Friedman, Alan Greenspan, Because why? Because the moon outlook, as Lynn described this morning, of what human beings are, is completely coherent with this insane, positivistic, empiricistic outlook. Now, what is it that these guys think the human beings can't do? Or what is it that they ignore? What is it that a guy like Leibniz really did? Well, in the simplest sense, what the Platonic outlook is that the human being observes empirical phenomena, but recognizes that this is just sense data that the organism, the human organism, is receiving. And there's a certain way in which the human organism reacts, so to speak, to these stimuli. They don't tell you anything. Everything is going on inside of you. Everything you see is going on in your central nervous system. It's the way which you as a human organism, including all the peculiarities of being conscious, idea generating and so forth, it's all occurring in you. In effect, you're always seeing the shadows in the cave. And the way the human mind works as a principle in the universe is certain anomalies come up as you study the universe. And you realize that those anomalies, those paradoxes, are the keys to figuring out what's really going on, to get you beyond. You want paradoxes, you want anomalies. If everything just went on linearly, all you'd ever know is that's going on and you're getting some version of it in your head, so to speak. You can never get outside of your head. Okay? But when a nice anomaly comes up, then you say, this is actually the way I'm going to... If I can figure out how that anomaly, how that paradox came into my field of experience, that will tell me what physical principles are operating, and I can grasp that with my mind. Now I can know something universal about what's affecting the way I experience things. And then you begin to get an idea about how the universe works. One good example of this is, of course, the case of refraction. Most people think, right, if you have, let's say, water or some fluid substance here, and you have a light beam, well, what's going to happen is, it's always going to travel. It's always going to travel in a straight line, because don't things always travel in a straight line? The shortest distance between 2 points is a straight line. Okay? Now, what do you find? You find actually that it doesn't travel in a straight line. It bends. It refracts. It bends. But you find something very interesting out. The way in which it bends is such that this path is the least time path. It takes longer if it takes a straight line, because of the nature of the way light is affected by the medium. And somehow that little old light ray knows to take a path which is quicker, which takes less time. And in fact, you can generate all kinds of interesting things off of this. In fact, it occurs in a fairly interesting lawful way. There's a refractive index for the medium, and it then is the path that it takes is related to the sine of the angle at which it hits the medium. So it's an interesting mathematical function, but it's derived from this idea of a least or quickest time. Or take what Kepler began to understand about the solar system. Because you look at the solar system, it's kind of wild. Things are moving forward, backward. They do loops in the sky. How in the heck do these things do this in this completely arbitrary way? Well, Kepler recognized that if you change a few things and recognize there's certain harmonic ordering of the relationships of planets in the solar system, and I'm taking this in the most general sense right now, you could look at all these anomalies and resolve them. First of all, by agreeing that the sun is at the center, and yet recognizing that the path of the planets is not circular. It's not uniform. The planets are constantly changing their motion, but in some coherent way. Thus, in 1609, Kepler generates the principle of gravity. as a principle. And there are any number of these. Now, one of the things I'm going to end now, I'll just come back a little bit later, is that these universal principles that are resolutions of anomalies tell you that the universe operates in a completely different way than simple experience. That it's governed by principles of action, principles of relationships amongst actions that are universal, that give us a way then of learning how these things operate. We can then generate hypotheses about the wave nature of light. We can develop that further. We develop all kinds of ideas off of this about electromagnetic phenomena and the full spectrum beyond light. All we call light is one part of the electromagnetic spectrum. That which we see, which we're attuned to. But you have infrared, you have ultraviolet, you have a whole range of these things. We begin to look at all of that. And our whole relationship to the world has been affected by these kinds of breakthroughs. Principles of least action, principles of quickest time, which were the entryway to our control of the electromagnetic spectrum, which generates ultimately the new mathematics of Gauss and Riemann, which is based on physical principles and not on formalisms. And these are the things that give us power over the universe. And it shows you that the human mind is an efficient force in the universe. So what I want to do is give Sky and Peter and maybe Jason, why don't you start to go into some of these examples of this. These should be brain teasers to a certain extent. And then I'll come back and say a few things at the end, more to this question of classical art. Okay?